3, the addition rule for probabilities. And we're going to look at how to determine whether two events are mutually exclusive and how to use the addition rule to find the probability of two events. Mutually exclusive is when you're completing one event and the events that you are looking to complete cannot happen at the same time. So another way to think of it is it's two events with no outcomes in common. In a deck of cards, if I asked you with one draw to pick out a jack, so event A is a jack, and event B is getting a king, there's no way that you can take one card out of the deck of cards and have it be both a jack and a king. So they have no common outcomes. And so it's impossible to do that set of events. So not mutually exclusive is when two events have common outcomes. So if I asked you to pick a jack, or I said with one draw, pick a jack or a diamond, that is going to be possible because there is in a deck of cards a jack of diamonds. So there is that possibility. So with one completed event, I could pick out a jack of diamonds. With rolling a dice, can we get a 3 and a 4 on one roll? And so with rolling a dice, that's going to be impossible. So this is going to be mutually exclusive. And that's because we have no common outcomes. Or another way you can think of it is rolling a 3 and a 4 on one roll is not possible. And by the way, how we'll represent these probabilities is using an OR. So this is the probability of getting a 3 or a 4 on one roll, which, excuse me, a 3 and a 4 on one roll, which is not possible. Could we randomly select a male student from college and randomly select a nursing major? So this one will be not mutually exclusive, because there are some male nursing majors. So we could select somebody who is a male and who is a nursing major. So if we look at a Venn diagram, we could have our males here, we could have our nursing majors here. Well, we would have some males that are also nursing majors. And then lastly, randomly selecting a blood donor with type O and randomly selecting a female with a female blood donor. So again, we have people with type O, we have females, and so there would be some females with type O blood. So this again would be not mutually exclusive. To find the probability of events that are not mutually exclusive, the probability of A or B, we're going to add up the probability of A, probability of B, and then subtract out any of the overlap. So for example, if I was looking at a college and there were, let's say, 1,000 males at that college, and then there's also 500 nursing majors, if I was going to find the probability of selecting a male or a nursing major, I would subtract out the people that are both male and nursing majors, because I don't want to count them twice. If we have mutually exclusive events, we would simply just add the two probabilities together. And so when we find these probabilities, we want to make sure we determine are they mutually exclusive, and then we can use one of those two addition rules. So we select a card, one card from the standard deck, find the probability that the card is a 4 or an 8. So finding the probability of a 4 or an 8. So these two things cannot happen at the same time, so these are mutually exclusive. So I'm going to simply just add up the probability of getting a 4 plus the probability of getting an ace, which is going to be 4 out of 52, plus another 4 out of 52, which is equal to 8 out of 52. And that would end up being about 15%. You roll a die, and the probability of rolling a number less than 3 or rolling an odd number. So the probability of rolling less than 3 or odd. If we quick look at the sample space, 1, 2, 3, 4, 5, 6. So probability of rolling a less than 3 would be the 2 and the 1. The probability of getting an odd would be a 1, a 3, or a 5. And that starts to determine that this is not mutually exclusive, because I could, with one roll, get a 1. That's both odd and it's less than 3, so it's not mutually exclusive. So the probability of rolling something less than 3 is 2 out of 6, plus probability of rolling an odd is 3 out of 6. But since that 1 is in common, I would subtract that out. So 1 out of 6. I would subtract out because I already counted that when I added up this 2 here. And so that's going to be 2 6 plus 3 6 minus 1 6, which is going to be 4 out of 6, or 0.667. So that would be our probability. So that 1 is making it so it's not mutually exclusive. So there, that could happen. That is part of both sample spaces. The frequency distribution shows the sales in dollars and the number of months which the sales representative reached each sales level during the past 3 years. Using this pattern, find the probability that a sales representative will sell between 75,000 and 124,900. So 75,000 to 124,900 would be this range right here. And there's no month that's going to fit into both categories, so they're either going to be one or the other. So this is mutually exclusive. So I would just take the probability of being between 75,000 and 99,999, and I would add the probability of being between 100,000 and 124,999. And so that probability would be 7 out of 36 plus being in this range is 9 out of 36, which gives me 16 out of 36 months, which would end up being a percent of about 44%. Lastly, a blood bank catalogs the types of blood, including whether they're Rh positive or Rh negative, given by donors during the last 5 days. The number of donors who gave each type of blood is shown in the table. And this is another two-way table. Find the probability the donor has type O or type A. In this situation, would be mutually exclusive. There's no one person that can have both O or A. So I'm going to take the probability of O plus the probability of A. And the probability of being O would be 184 out of 409. Plus the probability of being A would be 164 out of 409. And adding those two together, we'd get about an 85% chance. So 85% chance that they are either type O or type A. Probability that a donor has type B or they have an Rh negative. So probability of B or they're Rh negative. So looking at our probability of B, there's 45 out of 409. And then probability of being Rh negative is 65 out of 409. But when I add up these type Bs, I'm adding this 8 in here. And then when I'm adding up all these Rh negatives, I'm also adding that 8 in there. So that is not mutually exclusive. So there are some people who are type E or type B, and they are Rh negative. So when I calculate my probability, I'll have 45 out of 409 plus 65 out of 409 minus 8 out of 409. Because I don't want to count that twice. And that's going to leave me with 102 out of 409, which is about 25%. So our addition property depending on if it's mutually exclusive or not mutually exclusive, we can account for any of those overlaps or any of those events that have common outcomes, and we can subtract out those probabilities. Well, that wraps up day of the 3.3, and we'll head into 3.4 on Monday.